Hello friends, welcome to my YouTube channel, and I'm continuing the checklist series where I have dropped a previous video about other checklist, and now this checklist is about depressurization actually. And as you can see, I've got a template for this checklist, and let's go through this quickly and understand what are the key points for the depressurization calculations. So number one is that requirement of depressurization. That this means that operating pressure should be greater than 17 bar gauge pressure into volume criteria and volume of the volatile hydrocarbons, and this should be also verified with the project philosophy. So this is also given in your Shell DEP about these criteria. Okay, then identify applicability of the jet fire or pool fire in the system. Defense perform for both jet fire and pool fire based on applicability. So obviously we go for a pool fire. Jet fire only is done in some of the situation where it is especially told that jet fire is applicable. So I will make more videos how to calculate for the jet fire depressurization where there's a high heat flux, and I will prepare a separate video for that one. Number three talks about calculation done for both high and low pressure molecule weight of hydrocarbon, liquid and water removed from the system if it is not significant, because hydrocarbon has more effect on the giving the depressurization volume capacity. So it's better to remove liquid and water. Vessel parameter, volume, initial volume, equivalent height and diameter is defined correctly or not. You have to check that. Heat flux, use spreadsheet for heat flux parameter. Enable apply duty stream to the outside wall. Minimum vessel thickness excluding corrosion alliances. So had it been done or not? This needs to be checked, and mostly this is available in your HYSYS depression calculations. Nowadays we have got HYSYS blowdown calculation actually, which is again I will make a new video for that application. But for time being, we are discussing HYSYS depression software. Then number 8 says that during adiabatic depression, the cycle efficiency considered as 1% of gas and 100% for the light and heavy project philosophy. So this needs to be taken care when you are doing some adiabatic depressurization. Adiabatic depressurization is non-fired depressurization, where there's no input of the heat. The number sign 9 says that PV work contribution terms correctly selected, or fire case it is 0%, adiabatic 100% for the gas filled, 80% for the two-phase system, and 70% for liquid filled or the project philosophy. So this is again, we are talking about Aspen HYSYS depreciation, where they will ask for the PV work contribution. Number 10 talks about starting pressure correctly specified based on the project philosophy or not. For the adiabatic for fire adiabatic case, it is either PSV set pressure, PAHH, or maximum operating pressure. It will allow pressure for compressor. Pressure calculated from the isochoric flash. What is isochoric flash? Is like it is has been like in a isochoric is basically constant volume at and the trapped gas has been cooled down uh, for some time before for obtaining the settle out pressure. So that's called isochoric flash. So as you can see that starting pressure is also critical, and these are the parameters to be used for starting pressures. Then the final pressure number 16, sorry, it is some typo, it is should be 11. So final pressure correctly selected correctly as per project philosophy or survival estimation. So final pressure is mostly 6.9 bar gauge, and time limit is 15 minutes for fire case, and non-fire case it can be more. The local heat flux to be used to establish temperature profile, time for the profile, time for the depressurization. Mostly this is effective, like the peak heat fluxes for the jet fire case, where we have to see that that maximum heat flux doesn't increase uh, stress in the pipe. So it should be, so the time should be such selected that your maximum heat flux doesn't increase the stress and premature damage of the piping. Then we talk about like metal temperature are within the published limit of the temperature corresponding to the metal allowable stress. Same thing I was talking about previously. It is applicable for jet fire. When we do jet fire, because of the high heat flux, it are the chances that there is a premature loss of containment because of the damage of the piping. So you have to see that no depression time should be less so that the stress is within the limit of depression calculation. I will come to that one in my next video how to do it. Now this takes about surface average flux heat flux to use established pressure stress profile and peak depression load based on time calculated based on temperature profile. Then this so that's why this average heat flux again this is a kind of like jet fire depressurization, not for the pool fire. Where pool fire we calculate the heat flux based on surface area and dimensions. Then it talks about allowable stress are within the UTS limit of the metal for which we are talking about. Mostly it is talking about as a CS or SS lines. Okay. Then this talks about starting temperature for the isotonic flash is correctly selected as per project guidelines, like minimum open temperature, minimum ambient, hydrotom formation temperature. So basically, isotonic flash is used for calculating MDMD for the depressurization, MDMD of the material of the vessels, so that during initial phase, like when the trapped vapor is left for a long time in a cold climate, then and when we depressurize, the temperature likely to go very down actually, like sometimes it goes beyond the limits of CS lines, or then we have to go for LTCS or SS line. Mostly for methane rich gases, the temperature goes very down during the depressurization calculation. For the pressure, say 70 bar or 80 bar, and then going down to 6 or 7 bar in in some X time. So this is very critical that that we specify the initial temperature. Mostly client says that okay fine, go for minimum ambient or calculate what can be the minimum ambient temperature, start with the minimum ambient and minimum um, service temperature, and then start your adiabatic depression or isogenic depression. In isogenic depression, we calculate the final pressure based on constant density, where like suppose the starting pressure was 70 bar gauge and the temperature was like 40 or 50 degrees C. So if you keep this gas for some time, like 1 day or 2 day, what happens that temperature goes down, like it goes down to say 6 degrees C, 7 degrees C, and subsequently we have to calculate the pressure uh, to which the temperature has gone down. So accordingly, we calculate this starting pressure and then the minimum temperature which is achieved to calculate this isogenic temperature. So the final depression temperature goes down and it helps to understand whether MDMD is honored or dishonored. Then you said that adequate margin provided for MDFT predicted by HISIS or based on the project philosophy. So there should be some margin between MDMT and calculated temperature. Accordingly, you have to select your methodology. This is the quick video on how to go for a basic technique for depression. There are many actually, but I'm using this basic checklist for pool and jet fire depression. Thank you for watching this video. Do subscribe and like my videos. Thank you.